Hello. Hello.
Hello, ma'am.
Yeah. Good afternoon. Are you able to see the screen?
Yes, ma'am.
Okay. Our next topic is. Shall we start the class? So next topic is Unit 6, Arduino UNO, Raspberry Pi with Python and Smart City. All of you joined? Shall we start the class? All of you joined? Shall we start? Shall we start the class? Okay, today we are going to discuss about Unit 6, IoT physical devices and endpoints. In this, we are going to discuss introduction to Arduino, Arduino UNO, introduction to Arduino programming, installing the software, fundamentals of Arduino programming, IoT physical devices and endpoints, Raspberry Pi, introduction to Raspberry. So these are the topics we are going to discuss. All of you joined? Are you able to hear me?
Yes, ma'am.
Okay. So first we will see introduction to Arduino. So Arduino is an open source electronics platform based on easy to use hardware and software. It's a platform based programming device. Arduino boards are able to read inputs, light on a sensor, a finger on a button, or this Twitter message and turn it into an output, activating a motor, turning on an LED, publishing something online. So by using the Arduino boards, we can generate signals. It may be a light on a sensor device, LED a sensor, or it can recognize a fingerprint on a button, or it can send a message through Twitter. And by using it, we can activate a motor by turning on an LED light, or we can publish something online. So it is an firmware. It means that it is in between hardware and software, and we can program using firmware programming. Then what is Arduino UNO? So Arduino UNO is a microcontroller based board on an 80 mega 328P. So it is a microcontroller board. It's having so many components. So it is configured by using 80 mega 328P. It has 14 digital input output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 megahertz quartz crystal, a USB connection, a power jack, an ICSP header, and a reset button. So if you take the Arduino UNO board, it's having the following components. So here UNO means one in Italian, and was chosen to mark the release of Arduino software IDE. So while releasing the interactive display environment for Arduino, so they used the abbreviation UNO. UNO means it is number 1, version 1 in Italy. So it means that Arduino 1.0. So the UNO board and version 1.0 of Arduino software interactive display environment, where the reference versions of Arduino now evolved to newer releases. So initially they released Arduino UNO 1.0 version, initial version. Now we have advanced versions of Arduino. So this is the microcontroller board. So the figure shows you an Arduino UNO microcontroller board. It's having the so many parts, 1, 2, 3, 4, like that. The numbering is given. You take the overall, the various pins are, the number 1 is called reset button, 2 is AREF button, ground pin, digital input output, PWM pin, USB connection pin, TXRX pin. Like that we have 16 components, 15 components. So if you check each and every one in individual, see the number 1 shows the reset button. By using the reset button, we can reset the microcontroller board. So it means that we can reset to 0. So the ongoing process will be stopped, like microprocessor. I think we might have used 8085 microcontroller board, 8085, 86, 180, 80, 88. 186 to 86, like that, the same way. So the microcontroller board, the first button is called reset button. By using the reset pin, we can reset the ongoing process. This will restart any code that is loaded on to the Arduino board. Second pin is called AREF pin. The AREF stands for analog reference and is used to set an external reference voltage. So by using this pin number 2, AREF, it is you can measure the analog signal which is transferred through the board. The third pin is called ground pin. There are a few ground pins on the Arduino board. They all work on the same. So by using ground, because we have power supply, so using this ground pin, we can connect it to the ground. So fourth one is a digital input output. The pins 0 to 13 can be used for digital input or output. So here we have pins from 0, 0, 1, 2, 3, 4, 5, so up to 13 pins. Up to 12, totally we have 13, 14 pins. So those pins can be used for getting the input output signal from the Arduino board. So in 85 also we have 32 pin. No? The same way here we have 14 pins. Through these pins we can send and receive the input output from the Arduino board. The fifth one is called PWM. So the fifth pin is called PWM. This pin marked with the approximately symbol can stimulate analog output. So the fifth pin is specially used for creating the analog output through this approximate pin. And the sixth one is called USB connection. So the sixth pin, USB connection, we can connect the microcontroller board with other devices through this USB pin. So used for powering up your Arduino and uploading sketches. So through this we can connect the power source. Seventh one is called TXRX, transmit and receive data indication LED. So using the TXRX pin, we can transmit and receive data. The indication will be shown using this TXRX pin. So if your Arduino board is working, we can see the light, green light or yellow light through this TXRX pin. And eighth one is called AT mega microcontroller. This is the brain and it is where the program are stored. So the eighth pin is called AT mega controller. This is the main chip where programming operating system and all those components will be stored in the brain. It is called the brain of the microcontroller. So here the programs and other control signals, all the data will be saved in the AT mega microcontroller. So the ninth pin is called power LED indicator. So this is a power LED indicator. So through this pin, if the microcontroller is connected with the power source, it will blow green. If it is not switched on, it will show red. So this LED lights up these LED lights up anytime the board is plugged into power source. When the board is microcontroller is connected with the power source, then this LED light will glow in green. 10th one is called voltage regulator. This controls the amount of voltage going into the Arduino board. So using the 10th pin, we can regulate the voltage. So we need only 3.5 volts. So that will be transferred through this voltage regulator. 11th one is called DC power parallel jack. So the 11th one is called DC power. So this is used for powering your Arduino with the power supply. So this is the battery where it is through this we can power up the Arduino board. The 12th one is 3.3 volts pin. This pin supplies 3.3 volts of power to your project's output. To this, to the 12th pin, we can give power supply of 3.3 volts based on your project. 13th pin is called 5V pin. This pin supplies 5 volts of power to your projects. Through this 13th pin, we can supply 5 volts of power supply to the Arduino board. 14th one is called ground pin. There are a few ground pins on the Arduino and they all work in the same. So the 14th one is ground pin. Through we can give the ground connection to the controller. 5th one is analog pin. The pins can read the digital signal from an analog sensor and convert it into digital. So the 15th pin is analog pin. Through this, we can measure the signal and the analog signal will be converted into digital signal through the 15th pin. So these are the 15 main components or elements of our Arduino 1.0 or Arduino UNO microcontroller. So based on the, so here only by use in this microcontroller only we are going to program. We are going to program this microcontroller by using, I think you might have studied. Are you able to follow me? Hello. Hello. You understood what is Arduino 1.0 or Arduino UNO? Any doubt in the pin configuration, pin diagram? Any doubt? Shall we proceed? Are you there? Ritish, any doubt? Shall we proceed? So any doubt in the pin configuration? Shall we proceed? Are you able to follow me? Any doubt so far? Hello. Any doubt?
No, ma'am.
Yeah. So it is same as our 8085. I think you might have done microprocessor programming now. You studied 8085, 8086, and the 8088 pin configuration programming, microprocessor programming using 8085, 88 and 186, 286. So any doubt so far? Shall we proceed?
Yes, ma'am.
Okay, it is same as microprocessor only. So after once you understand what is the pin configuration, then our next topic is simple programming based on Arduino UNO board. So in Arduino UNO board, we can make use of the following programming constructs. So if you want to use any create programs, we will use the following commands. So the fundamentals of Arduino programming, two required functions are called functions, methods, or routines. So here we are calling the functions as, we can call it as functions or we can call it as methods or routines. All are same. So functions are nothing but if you want to perform any function, we will create some small code. here the main two functions in Arduino UNO are setup function and loop function. The first function setup, the default template will be like this. So we'll have the return type followed by the keyword setup, opening bracket, closing bracket. Within the flower brackets, we'll write down the code. So the once if you call this function, it will execute one time. So here void means the return type is void, so it won't return anything. So the function name is called setup. So we can configure the Arduino UNO board by using setup function. So the second function is called void UNO, no, void loop. So using this loop function, you write any code within the loop that will be repeated for a number of times until the condition is satisfied. Once the condition is not satisfied, it will come out from the loop. So the main two functions or routines or methods we are using in Arduino UNO board are setup function and loop function. Both the functions are void functions. It means that it won't return anything. If you want to execute the function only once, we will go for the setup function. If you want to repeat the same function for a number of times based on the constraint, we'll go for the loop function. And other various components what we will use with Arduino UNO are, so we'll use some digital writer. If you want to write or configure the digital writers, we will use the function digital write. And if you want to write analog output, we will go for the function called analog write. Here the digital is a keyword, write also a keyword. Digital all small letters. The write first letter is capital, so it is case sensitive. So we should write. So the digital write is a keyword. We should follow the same syntax. Digital in small, W in capital, write in small. So the second one, analog write, it is used for writing the analog output. The third one is called digital read. So using the digital read function, we can read the content from the controller board. And the fourth one is called if statements and Boolean statements. If we can make use of the if statements, and we can simple if statement or simple if else statement or nested if then else statements we can make use, and it can return we can make use of the Boolean functions also. It will return true or false value. And we have analog read function. It is used to read the analog signals, and serial communication that can be performed. So these are the various functions or methods which we can make use in Arduino UNO board. And if you want to write comments and in the programming, we will use the comment statement. So same as like C++, we can make use of the comment statement. If you want only one line to be comment, we'll use a double backslash. So whatever written followed by double backslash will be taken as a comment. It's only for programmer's reference. It means whatever any logic or any tricky word or any explanation, the comments can be written after the following a double slash. If you want to make more than one line as comment, we can make use of backslash asterisk and a asterisk backslash. Whatever is written within backslash asterisk and asterisk backslash, multiple lines of comments will be created by using this syntax. So backslash asterisk and asterisk backslash will be taken as the beginning and end of the comment statement. It is for users or programmers reference. And this diagram shows you a small program written in Arduino 1.0.5 bare minimum. So here what we are writing is, say for example, they are using some command lines. So they are putting backslash, whatever name of the sketch, brief description, date of the program, all those things, author name, all those things can be written within double backslash. So these are the command lines, followed by they have void function, void setup function. This will be executed only once, and void loop function. This will be repeated for a number of times until the condition is satisfied. So this is the Arduino editor. We have same as our text editor. We have options like file edit, sketch tools, all these things. And the three commands we can make use in Arduino UNO board, or we can make use of pin mode, digital write mode, delay mode. So these are the main three command statements or executable statements we can write in Arduino UNO. So the first command pin mode, pin comma UN. So the syntax of this pin mode command is pin is small, M is in capital mode. So pin mode within opening and closing bracket, followed by semicolon, we will write down the pin number followed by input mode or output mode. So we are configuring the pin as input pin or output pin using this command. Say for example, the executable statement will look like this: pin mode 13 comma output. It means that the pin number 13 is made as output pin, so where we can receive the output of the program. So pin mode 13 comma output. The second command is called digital write. Here also write is in capital, digital write. So this is a keyword. So followed by within opening and closing bracket semicolon, we'll have the pin number followed by I or no. Say for example, the executable statement will look like this: a digital write 13 comma high. Here the pin 13 is high, set to high. It means that it is in high 1 or 0 like that. So the another command is called delay time in millisecond. So delay is a keyword followed by opening bracket, closing bracket, semicolon. We'll specify the how much time we want to delay the process. So delay is an routine or subroutine or executable function. So using this, we can introduce delay in the ongoing process. So that much amount of time the process will be delayed. Say for example, the executable statement for delay will be delay comma 2500 milliseconds. So here it will introduce an 2.5 thousand milliseconds, that is 2.5 seconds of delay will be introduced in the ongoing process so that we can see the output. So these are the main three commands we will make use in Arduino UNO board: pin mode, digital write mode, delay function. So the commands are, each and every comment is an case sensitive. The syntax is case sensitive. So we should write, if you instead of mode, small mode, if you instead of capital M, if you use small m, it will create error message. The same way, we should say high in full capitals, otherwise it will create error message. The same way, we can make use of any pin 1 to 13 pins for configuring the pins. So any doubt in these three commands, what we are using in the Arduino UNO board? Any doubt? Shall we proceed? Any doubt in the executable statements? Shall we proceed?
Yes, ma'am, we can proceed.
Okay, next we are entering into, after the three main commands, we are using so Arduino programs run on two basic function sections. So we already discussed, we have two main functions: setup function and loop function. So using the setup function, the commands which are written within setup function will be executed once. Say we can set up the motor or we can set up the sensor. The sensor configuration and the setup configuration will be mentioned in the setup function. The same way, using the loop function, get information from sensors and send commands to motor. So using this loop function, it will be executed, repeated for a number of times based on the conditions written in that. We can send information to sensors and motors using this function. So what is setup function means? The setup function is used for assigning input and output. And example, say motors, LED, sensor can be configured using this setup function to ports on the Arduino board. It also specifies whether the device is input device or output device. So in the setup function only, we need to configure we can configure the instructions for motor, LED, and sensors, and we can make it as motors as accepts input, and it may be an input device or output device. The various input output configuration can be mentioned. To do this, we use the command pin mode. Through the pin mode, we will configure the devices, and that will be assigned to the corresponding any one of the So they are explaining you the set of function. This typical set of function in Arduino UNO board will look like this. So we'll have a void setup within opening bracket and closing bracket. We'll use we are using the function called pin mode. Here we are configuring the pin. Now the pin port number 9 is set as output port. So we can see the output of our execution in the port number 9. So this is the typical syntax of our setup function. So here 9 means the port number or pin number, and output is output. The port number 9 is assigned as output. And if you take the loop function, it will look like this. So we'll here we are using some port instructions, commands, digital write 9, high. Here the pin number 9 is set to high. Then we are introducing delay of 1000 milliseconds. So it means 1 millisecond delay will be introduced in between digital write and another digital write. Initially, we are setting the digital write port number 9 as high. Then the delay will be introduced for 1 millisecond. Then we are assigning the digital write port number 9 or the pin number 9 as low. So it will stay in the high state for 1 millisecond. Then it will come to the low state. Then the 100 milliseconds will be, again it will stay in the low state for 9 milliseconds. So this loop will be repeated based on the constraint. So here 9 means the pin number or port number, and here high low means that the turn the LED on or off, wait for 1 second or 1000 millisecond. So this is a typical example for a loop function. So declaring a variable. So we can declare, make use of variables in our Arduino given mode. While declaring the variables, we will use the data type followed by variable name, and we can give some initial value. Here they are declaring the variable int value equal to number 5 semicolon. So it is a declaration statement. It starts with the data type followed by variable, some assignment statement, and the constant value, and a semicolon is used. So here VAL means variable name, and it is an assignment, and 5 is the value assigned to the variable. So using how we can make use of the variables in Arduino UNO means here we are introducing two variables, int delay time, it is 200 milliseconds, and int green LED equal to 9. Here the variable green LED is a variable, it is assigned the value 9, and void setup pin mode green LED comma out delay declare delay time where V is the variable. So here green LED is the pin number 9. The pin number 9 is assigned as output pin. Then in the loop within the loop statement, what we are doing, a green LED equal to high state, then delay time. So it will stay in the pin number 9 will stay in high state for 9 high state for 2 milliseconds. Then the same pin number 9 or port 9 is assigned to low state, and it will stay in the low state for another 2 milliseconds or 2 seconds. 200 milliseconds or 2 seconds. So in this way, instead of using the port numbers directly, we can make use of the, instead of using the port numbers directly, we are assigning the delay time as 200 milliseconds and the green LED as pin number 9. So wherever we use the keyword, we use the variable green LED, it refers to pin number 9 or port number 9. And the same way using variables, how we can make use of variables in Arduino UNO board means we can make use of, here we are using the delay time of 200 milliseconds green light LED. Then what are the conditions we can make use? So this is how to use variables and how to configure the variables and make use of the variables. Then conditions, the various conditions what we can make use in Arduino UNO board are to make decisions in Arduino code. We use an if statement. If statements are based on true or false question. So we know very well if some condition, if the condition is satisfied, the following statements will be executed. If the condition is false, the statements followed by else statement will be executed. So here the condition may be true or it may be false. So to here output of the execution of if statement will be true or false. So they're given some examples. So we can make use of greater than symbol, less than symbol, equal symbol, greater than or equal to symbol, less than or equal to symbol, or not equal to symbol. So if you want to represent a greater than symbol, we here A, B, C are variables, A greater than B. If you want to use less than symbol, we can make use of A less than B. Equal to symbol means double equal to, and greater than or equal to symbol means greater than or equal to B, and less than or equal to means A greater than A less than or equal to symbol, not equals means not equal to symbols. So these are the symbols that it means these variables and we can make use of variables, if statements, conditional statements, and relational operators like greater than, less than or equal to, greater than or equal to, not equal to, double equal to. Relational operators also we can make use. These relational expressions we can make use along with if statements. So the result of the if statement will be true or false. So the all those things we can make use in almost the C functions like statements we can make use in Arduino UNO board. So say for example, the typical if statement in Arduino UNO board will look like this. If the condition is true, then perform some action. So this will be the example or syntax of if statement. If some statement, if the condition is true, then perform the operation which is given within flower brackets. Say integer count equal to 0. Here count is a variable, void setup. The setup function serial begin 9600. So void loop function, if counter is less than 10, serial println. So this function serial println will be executed. It will count for the counter will be initiated and counter equal to count plus 1. So it means that the loop statement will be executed for 10 times because the initial value of counter is 0. So it will execute for count equal to 0, 1, 2, 3, 4 up to less than or equal to 10. So less than 10. So it means it will execute from 0 to 9 times. And input output, the transferring data from a computer to an Arduino is done using serial transmission. So from the microcontroller Arduino board, we can transfer the data in the form of serial signals to the computer. To set up serial communication, we use the following statement: void setup serial begin. So if you say serial begin using this function, we can communicate from the computer to an Arduino board, and it will start transferring the data in the serial transmission form. Serial transmission in the sense it will send the data in the form of digital signals one by one. Writing to the console. So we can write the data whatever we received from to the console, that is operating system. Void setup serial begin 9600. So we are establishing a communication between the Arduino microcontroller to the computer using this serial begin function. Then we are writing the statement serial println. So the word hello world will be printed on the console. Then we are calling the function void loop. So using serial println function, the data, this data will be written on the console, and we are establishing serial begin using this function. We are establishing the connection between the computer to the Arduino board. If else condition, if the answer is true, then perform some action, else perform another set of actions. So we'll check for some condition. If the condition is true, if the condition is satisfied, the functions followed by if will be executed. If the condition is false, so the first statements followed by else path will be executed. So they've given you an example: int count equal to 0, void setup serial begin. So using this setup function, we are establishing the connection between the Arduino UNO board to the computer. Then the statement loop statement function will be executed. If counter is less than 10, so the state function will be executed from 0 to 9 times, 10 times. So what we are doing is it will check for the condition. Initially the counter is 0. Now 0 is less than 10. The condition is satisfied. Then it will execute the function serial println less than 10. So this statement will be printed for count equal to then it will else it will print the serial println greater than or equal to 10 serial end. So the communication between here serial begin means that the connection is established between Arduino UNO board to the computer. Through this serial end, we are ending the connection between computer and Arduino board. And by using this looping statement and by making use of if else statement, we are writing the following line less than 10 for 9 times. So the if statement will be executed for 0 to 9. Once it becomes 10, it will go to the else part and it will print greater than or equal to 10. Then the serial end function will be executed. Then the connection between the computer and Arduino board will be disabled. We can make use of if else if statement also. So if else if condition. So we can make use of nested if statement. If condition will be checked, if the condition is true, the statements will be executed. If the condition is false, it will check another condition. Else if second condition will be checked. If both the conditions are true, then the statement for if first condition is false, second condition is true, then the statement followed by else if will be executed. So they given you an example, int counter equal to 0, void setup, serial begin. We are establishing the connection between computer to the Arduino board using loop statement. We are checking for the counter value. Initial value of counter is 0. And the when this counter value is 0, the loop will be executed. This condition is true. Again, else if part we are checking, this condition is false. Then when a counter is 0, this condition is true. So then this statement will be executed. Once the value become 10, it will come to equal to 10. It will print equal to 10. During the next loop, when counter become 11s, it will execute the else part. Then it will print it is greater than 11 is greater than 10. So this statement will be less than 10 will be displayed for 0 to 9. Once counter become 10, it will execute if 10 is equal to 10. Once counter become 11, it will display 11 is greater than 10. So in this way, we can make use of else if statement also. The next one is called Boolean operators. So here we have Boolean operators like and, or, not. We can make use of the and operator by using the notation double address operator. So this is the way to make use of and operator. If you want all the conditions to be true, we need to use and logic or and gate. We use the symbol double address operator. Say for example, if value is greater than 10 and value is less than 20. So if the value is in between the range 11 to 19, then the condition will be true. If the value is 0 to 9 or if it is more than 19, the condition is false. So we can combine two relational expressions by making use of and operator. The and symbol what we are using is double and. The same way we can make use of or operator also. So the or operator symbol is the double. Or operator symbol is double. If value is less than 10 and or value is greater than 20, if the condition is true, it will be executed. If you want either of the conditions to be true, we need to use or logic or gate. We use the symbol. So if this or that, any one condition is true, the result will be true. If both the conditions are false, then the result will be false. So or we know very well, or is logical addition and is logical multiplication. So if both the expressions are true, then only the result will be true, because we are using logical multiplication. And is equal to logical multiplication. Here we are using logical or is a logical addition. If any one of the condition is true, then the result will be true. So how we can make use of the Boolean variables in our Arduino programming means, here we are using the keyword Boolean, means the data type is Boolean. The variable is done, it is equal to true. So done is a variable, it is of Boolean type. The initial value is true. Boolean done equal to false. Void setup, where we are establishing the connection between computer and Arduino board using 9600. Serial begin. Void loop, if done, if the condition is true, that is if the value of done is true, not true, then serial println hello world done equal to true. So here it will check for the variable done. If not done is if the condition is true, then the result will be the hello world will be printed. Then we are assigning done equal to reassigning the value of done equal to true. Then the condition, until the condition is true, it will be executed. So other important functions what we can make use of in Arduino board are serial println, pin mode, and digital read, digital write. So these are the other operations. Serial println is used to print or write some value to the console. Prints the value to the serial monitor on your computer. And pin mode is used to configure the pin, configures a digital pin to read input or write output to a digital value. So we can assign some pin as input pin or output pin. And the digital read followed by pin reads a digital value. It may be high or low on a pin set for out input. So digital read means it will read the value from the particular pin and it will take it as a input. And the digital write means pin number followed by value. So once some process is completed, the output of the process or result will be written in a particular pin. So we are passing the pin number as well as value. So we are writing the value result output into the particular pin. And here we are reading the input from a particular pin. Here we are configuring the pin as input pin or output pin. Here using serial println, we are initializing the connection between the Arduino board to the computer. Output outline, essential programming concepts. It is used for delay purpose to stop the infinite loop, and it is so here in the following section we are going to discuss the following topics. So any doubts so far? Any doubts so far?
No, ma'am. So in the following section, we are going to discuss the following topics. So the essential programming concepts: delay, infinite loop, general input-output configuration, polling or busy wait, input-output, interrupt processing, timers and internal interrupts, high-level languaging extensions, code transformations, and for enabling computing, loop unrolling, loop merging, loop peeling, and filling. So first one is called delay. What is delay means? So we know very well we can introduce delay or it is a time delay. So in the ongoing process, by using delay, we can introduce interrupts. So we know we have different types of interrupts: maskable interrupts, non-maskable interrupts, interrupt 1.1, interrupt 2, interrupt 3, like that we have. And we have if it is uninterruptible process, we cannot stop the process. So usually in the microprocessor programming as well as in firmware programming, we are making use of the delay function to introduce the or to introduce some delay or to stop the ongoing process for some time. Delays are essentially in embedded systems, unlike high performance systems where we want the program to execute as fast as possible. So delays are used to synchronize events or read inputs with a specific sampling frequency more on bus wait or input output. So it is in most of the embedded systems, we are making use of the delays for high performance systems to the program to execute as fast as possible. Say that the code shows how we can introduce a delay. Okay, so how do we build a delay function? Our reference is the system clock frequency. We use a register or timer to measure ticks. So each tick is one frequency. So example, assuming a 16-bit processor and an increment and jump instruction is 1 cycle each and 10 megahertz system clock building 1 second delay. Say for example, we are taking the time cycle t equal to 1 by 10 megahertz because the processor's 16-bit processor, the processing speed is 10 megahertz. It is equivalent to 100 nanoseconds. So 1 second or 100 nanosecond is equal to 10 lakhs seconds. So for example, how we can introduce delay means int I equal to 50 lakhs two tricks per iteration, back equal to, so the process will be repeated I minus minus. If I is not equal to 0, go to back. So we are introducing a label. So it will check for the I value. If I is not equal to 0, until I is not equal to 0, it will go to the label back. So again, it will come here. Initially, the I value is 50 lakhs. So it is not equal to 0. It will go back to back. Again, I will be decremented. So the process will be repeated until I becomes 0. So in this way, we can introduce a delay. The next one is called infinite loop. Infinite loop means the loop will not stop. It will go in repeat in for loop, while loop and all. We will get if some error is there. If it becomes an infinite loop, then the loop will go in multiple iterations. Embedded systems are mostly single functioned. Their core application never terminates. So infinite loops are not forbidden as long as they are done correctly. So in embedded systems like our microcontroller or UNO board, we are executing one function at a time. So here there may be no chances of getting multiple function execution, and if more than one function is executing at a time, there may if one function is not responding, and if it is waiting for the another function to complete, then we will get the hanging problem and infinite loop problem. But in Arduino UNO board as well as in most of the embedded systems, we are executing one function at a time. So these kind of problems may not occur. So here we can check the infinite loop by using the following code. Void main, we are having the main function, light enumerated type, red, orange, and green. So we are using an enumerated data type. It is same as array. So an array of, it is the return type is light. So here the fixed values are red, orange, and green. So it is an enumerated data type. Loop and light equal to red. Initially, the variable light is assigned as red. No exit function from loop. Then the delay of 20 seconds is the red light will glow for 20 seconds. Then we are assigning the light as orange. The orange light will glow for 2 seconds. Then we are assigning, because we are introducing delay, so this will be delay. The light will take the orange LED for 2 seconds. Then light equal to green, it will be stay in the green light for 20 seconds. Here we are introducing 20,000 milliseconds to 2,000 seconds and 20,000 milliseconds. So the loop will be repeated until the loop ends. Here there is no condition to stop the ongoing process. So this will go to loop. Again it will go to loop. So this will go in infinite loop. So the light function will take different colors, red, orange, and green, with delays of 220 milliseconds and 2 milliseconds, 20 milliseconds. It will go in infinite loop. So in this way, we can introduce delay. So any doubt so far? Yeah, shall we continue with the next topic? The next topic is Raspberry.
Point. Cosa nivelno?
So for additional reference,
This material also I have uploaded already. Are you able to see the screen? Are you able to see the screen?
Ma'am.
Yeah, this material also I'll already uploaded.
Arduino,
And,
no.
and today's material also I will upload. And I will upload.
Arduino.
I will upload one assignment based on today's class. Now we'll have phone. I will ask you a small question. You need to answer.
Ask a small question.
I think you got the idea about Arduino. I will upload the quiz questions in Google Classroom. To try to submit the answer for all the. It will be multiple choice type. Will be asked 5 or 10 questions. You need to choose the correct answer. Today we discussed Arduino UNO board and its configuration, pin configuration, and how the board will look like. What are the functions we can use in Arduino board, like setup function and loop function. What is the syntax and semantics of audio syntax setup function and loop function, and the various arithmetic and logical operations that we can make use in Arduino board, like looping statements, if then else statements, if statement, if then else, and nested if statement, and the various pins, how to configure the pins, and the serial configuration, parallel configuration, how to assign the pin numbers and port numbers, how to establish the configuration, the serial connection between the computer and computer, that also we discussed. So with this, we are coming to an end of Arduino UNO, the configuration and the simple programming. So in Arduino UNO, we can make use of all the C++ library functions, C and C++ readable code, C and C++ readable codes and assembly readable codes, machine language instructions. We can make use of global variable declaration, setup function, loop function. So we will have variable declaration followed by initialization and looping statements. So this will be the sketch of our Arduino board, and the diagram shows you how to set up the configure the setup function and how the loop function will execute. So in setup function, we will assign the pin mode, set pin as input pin or output pin, and serial begin. Using that, we can establish the connection between our Arduino microcontroller to the computer, set to talk to the computer. And in the looping statement, we can make use of the digital write function, digital read function, and wait function. So digital read is used to write the output, set digital pin as high or low, and read
digital read, read a digital pin state, and wait function is used to wait for an amount of time or introduce a delay. So this also we are programming the various data types. What we can make use in Arduino board are we can make use of integers, Boolean functions, characters also we can make use, and floating point data types like floating the numbers with the fractions. We can make use of the exponential data types also. The scientific notation can be used. So we are using whole part, decimal part, followed by e plus to the power of plus 38. So it can accept the values from 3.4 e to the power of plus 38 to minus 3.4 e to the power of plus 38. So, and it can store 32 bits of data of 4 bytes. And it will accept long data types from the range of this to that, and it will accept 32 bits of 4 bytes of information. And in Arduino board, we can make use of string functions. And on Arduino, there are really two kinds of string functions: strings with a lower case, and that can be created as an array of characters or a type character using, and we can have a string with capital letters. The strings will be written within double quotes in is a string type of object. So we can make use declare the variable as character string array of 10. So it will accept the value 10 characters within double quotes. We are assigning some initial value. And the same way string object here already the string is declared. We are assigning some new value to the string. And in the various libraries, what we can make use in Arduino, or libraries provide extra functionality for use of sketches. Example, working with the hardware or manipulating data to use library near sketches. Select it from sketch import libraries. So we can make use of the existing library of data in our Arduino board. So the various standard libraries, what we can make use in Arduino board are EPROM, reading and writing to permanent storage, and so erasable and programmable read-only memory. We can write the data in the permanent storage space. Ethernet 2 for connecting to the internet using the Arduino Ethernet Shield, Arduino Ethernet Shield 2, and Arduino VTH. For Meta for communicating with applications on the computer using the standard serial protocol. And we can make use of GSM for connecting to a GSM GRPS network with the GSM Shield. So we can connect an GSM Geo. So to measure to identify the location, we can go for a GSM kind of devices. And liquid crystal for controlling liquid crystal displays, LCDs. We can make use of the liquid crystal keyword. So these are the standard library functions which are inbuilt in the Arduino UNO board. So EPROM is a built-in function. Ethernet 2 is also a built-in function. And for Meta, GSM, liquid crystal, SD, reading the and writing SD cards, standard secondary devices. You want to write the data into the secondary device, or you want to write the output into the secondary storage device, we can go for SD function. And servo function for controlling servo motors. And SPI function for communicating with the devices with the serial peripheral interface, SPI bus. If you want to communicate directly with the serial peripheral device, we can go for SPI functions. Stepper for controlling stepper motors, and TFT for drawing text, images, and shapes on the Arduino TFT screen. If we want to draw textual information or images or shapes on the Arduino TFT screen, we can make use of TFT function. Wi-Fi for connecting to the internet using Arduino Wi-Fi Shield. So we already discussed how the for loop statement is used in Arduino board. So we are using setup function. Then within the loop function, we are using for loop for I equal to 0, I less than or equal to 255, I plus plus within opening and closing bracket. We are introducing analog writer. So it will write the output on the PWM pin. So we have PWM pin in the Arduino controller. So there it will write the value of I. So the for loop will be executed for 0 to 255 times. It means 256 times the loop will be executed. So it will write the value from 0 to 256 on your Arduino pin of PWM pin, and it will be written with a delay of 10 milliseconds. In the same way, we can use of if-else statement, and we can make use of switch case statement also. We know very well switch case statements are used to choose an option from the existing list of options. So switch will check for some condition, check for the value. If the variable matches with any one of the cases, then the corresponding case will be written on the corresponding case will be the output, or it will choose if the variable is not matching with any of the cases, then the default case will be executed. Switch within brackets some variable. If the variable is 1, the case 1 will be executed. If the value of variable is 2, case 2 will be executed and break, and it will come out from the switch case statement. If the variable number is not matching with any of the cases 1, 2, 3, then the default case will be executed. So the same way, we can make use of for statement for initialization value, condition, and increment value. The for statement is used to repeat a block of statements enclosed in curly brackets. An increment counter is usually used to increment and terminate the loop. The for statement is used for any repetitive operation, and it is often used in combination with arrays to operate on collections of data ins. So the for loop will start from the initial value, and it will check for the condition until the condition is not satisfied. Until the condition satisfies, the statements within flower brackets will be executed. Once the condition is not satisfied, it will come out from the for loop. We can make use of while loop also. While the condition, then it will execute the statements. If the condition is true, then only it will execute the looping statements. If the condition is false, it will not enter into the looping statements. So first we are checking the condition, then we are executing. If it is do while, we'll do the process once, then we'll check for the condition. And in while statement, we'll check the condition first. If the condition is satisfied, then only we will execute the statements which are in the flower brackets. So do the statements, it will execute the statements once, then it will check for the condition. If the condition is true, again it will repeat the process. So this statement also we can make use as it is in Arduino UNO board. So if you want to install Arduino in your system, to install the Arduino IDE, interactive display environment, and connect to your Arduino board to your computer via USB. So we'll go to the web page http://arduino.cc.english/guide/mac/OS X. So from this particular website URL, we can download the Arduino software, or we can go to the another link, Arduino English Windows. From this is for Windows operating system, this is for Macintosh operating system. And if you want a Linux version, we'll go for this particular link. So we'll go to the link Arduino CC EN Guide Windows. From there, we can download the Arduino microcontroller programming. Arduino editor will be downloaded. I have uploaded this material also. These also interrelated to your topics. Just go through it. But the previous PPT is based on your syllabus and based on your textbook. And these are some additional resources where we can find some more information based on Arduino UNO. So this is your typical Arduino board, and the board will look like this. So this is your board, and we have different versions of Arduino board, R3 front, R3 back. So this is the front side, back side of your Arduino board. This is Arduino UNO R2 version, this is R3 version, and this is the basic version Arduino UNO, that is Arduino 1.0. Just to go through the components to understand the Arduino board better.
Internally गर्यो.
Yeah.
Internally गर्यो. And अर्को एउटा कन्डिसन हुन्छ externally. EXTERNALLY. Externally को लागि के हुन्छ?
Okay. Any doubt so far?
अर्को point जो P point यहाँ P छ, यसले पनि डिवाइड गर्न सक्छ के यसले. बुझ्यौ? Point यहाँ छ P.
Okay, any doubt so far?
कसरी डिभाइड गर्छ नि त्यसरी नै क्या पोइन्ट पी ले अझै पनि बाहिर भए पनि हैन डिभाइड गरे हैन नि त बाहिर छ नि त त्यही पनि डिभाइड गर्छ क्या बुझ्यौ पोइन्ट पी चाहिँ बाहिर भए पनि डिभाइड गर्छ कहिले काहीँ त्यसले के हुन्छ
Okay, go through the content. If you have any doubt, ask me in the next class. I will upload the assignment questions in the Google Classroom. You answer the questions. It will be of multiple choice type, 10 questions. Each carries 1 marks. And you submit the answers along with the answers in the Google Classroom itself. And the question will be based on your Arduino UNO board. Okay. Shall we end the class?
Yes, ma'am.
Yeah, you go through the content. If you have any doubt, ask me in the next class. Okay. So next
Sure,
class
ma'am.
is next class is on Thursday. Okay.
Okay.
And I will upload the assignment in the Google Classroom. Okay. Those who are not submitted the previous assignments, I think so far I have uploaded 4 assignments. Some people not yet submitted, some 3 and 4 assignments. If please submit that also. Okay.
Sure, ma'am. Thank
Yeah.
you.
Yeah. Thank you.